That was so perfect. No, nobody saw it. Like, I ripped it off of the thing so perfectly.
That only happens once in a blue moon.
No, look, Chandler, you see this?
Yeah.
If only grades were based upon that.
I would be passing everything.
Grades were completely luck-based. I would not survive.
All right, questions on the homework?
No, sir.
What if I can shape my homework by accident?
Number 9, right.
Oh, yeah.
That only
We didn't
took
even talk
12
about
months.
number
I even had my honors kids that said, okay, we had problems with number 9. I said, see, you guys can figure it out. And they spent the entire class. One kid figured it out all by himself, but he didn't figure it out. He said it took him about 15 minutes to figure it out too. We were on par with everyone else. All right, no questions? All right, let's go over this. 1 through 12. Oh, 1 through 12. Oh, I'm on the right page. I am on the right page. I didn't list the right page. It's actually no, I did. 169. Never mind. That's in the classroom exercise.
What's the date?
The date is the 19th. All right, here we go. Number 1 is CR and CE. Now, you could have written them backwards, RC and C. Number 2, all the angles that are congruent. There's lots of them. REC, WCE, WEC. Number 3, okay, that would be ER, RC, and CW. Now remember, ER could be written RE. And then number 4, all the angles. That would be CRW, CWR, and EWR. Make sense? Okay? All right. Number 5, lots of answers here. A is 8, B is 10, X is 118, and Y is 62. 2 ideas there. 1, remember all the angles on the quadrilateral add up, interior angles add up to 360, so you got to use that back. And the opposite angles are congruent. All right, number 6, A is 8, B is 15, X is 80, and Y is 70. And then it gets, 7 through 10 are messy. 7, A is 5, B is 3, X is 120, and Y is 22. Number 8, it even gets more messy. A is 9, B is 11, X is 33, and Y is 27. 9 isn't that messy. It was just for some reason it struck us all as being hard to figure out. And the way you solve number 9 is it turns out there's isosceles triangles there, so it uses that along with the fact it's a parallelogram. A is 8, B is also 8, X is 56, and Y is 68. Number 10, you got a right angle there. That's actually a rectangle. We just don't know it yet. Be a couple sections before we get to rectangles. A is 10, B is 4, X is 90, and Y is 45. 11 is 60, 60. 12, ST is 14, and SP is 13. And that was it. They're hard. They're hard, like no joke. Just so that you know, calendar-wise, we're going to, on Wednesday, we're going to go over all of this again. So we'll take an entire day. I'll give you a worksheet, and we'll do it one problem at a time. We'll make sure you're going to get a couple things today. You're going to get a couple things tomorrow. It's going to seem very overwhelming. So we're going to take a full day, and we're just going to do nothing but skills. It won't be doing proofs or anything like that. It'll just be, here's the quadrilateral. It's going to be a parallelogram. Figure out this side or figure out this angle. And we'll do this to our heart's content, or we'll do it until we're tired of it, that sort of thing. So if you're slightly confused right now, that's about where you probably should be. If you're not confused, great. But if you're slightly confused, that's okay. That's about where I would expect it. If you're very confused, that's kind of an issue. All right, make sure today we go from very confused to slightly confused, and we'll be okay. Yeah.
What exactly should we expect on career day?
So this is Friday. It's just for 9th and 10th graders. So we're going to have a number of speakers come in. We can't like have anyone that, oh well, I listened to 6 speakers and they're all boring. I'm sorry, we can't like You know, if that's not what you're into, that's not what you're into. So we purposely just try to get as many, you know, diverse careers as we could to talk to you. They're just going to explain their experience of what they do on a daily basis, what their education was like how did they get to this job, just so it starts you in that process of thinking about what's going to happen in 2 years. 2 years, you're either getting a job or you're going to college, one of the two. And so as sophomores, you need to, you know, start moving your mind into that mindset. The second thing we'll do is the end of the day, we're going to have our college counselor just talk about the college application process. You know, just like really broad terms of what does it look like and what are the basic timelines. Like, what should I be doing right now versus what should I be doing next year? I mean, next year is when it all happens for you guys. Next year is when you start making your final decisions of where I want to go. When you start doing all your college tour, and we're talking about if you're going to college, where you start doing your college tours, where you start thinking about, can I afford this? You know, how am I going to pay for it? And you take your tests that determine, you know, whether you can get into the college, all that jazz. So that all happens like a little bit over a year from now. So it's not, doesn't literally happen a year from now, but the spring of your junior year is when you take your SAT for good, right? You take, and some people take it more than once. So they take it into the summer, and some even into the fall of their senior year. But you have to have your applications in by like November-ish. I'm not the college counselor, but so, like November-ish of your senior year. So that means the summer of your end of your junior year is when you start writing your essays. When you have to have you know, recommendations from teachers. So you go to your favorite teacher and you say, please write me a recommendation that I'm a great student, that sort of thing. All that stuff. So you guys got to have visibility on what that looks like. So that's what Career Day is about. More to follow on that. The college counselor will be meeting with you personally as the year goes on this year, and then obviously next year it gets more intense. But that's what Career Day is like. So no work that day. So I mean, it's pretty good, cool day. All right. Yeah. Homework tonight, right now, please. I will come around and grab the homework. Really, only one page here. I shouldn't have even printed out some of the ways. No homework for that? You guys got a test available today?
Oh, it's
We do.
You're testing chemistry. You're testing
We have had homework over there.
I passed the
Yeah.
Most of what we're going to do today, I need you to put in your book of truth. Most of what we do. Turn around. Me personally, this was kind of where geometry got a little bit, yes or no? Oh, that's your.
That's just notes I ripped out.
This is where it kind of got a little bit confusing for me, because these sections come really fast, really quick. You get lots of things. We haven't really been getting a lot of things, and all of a sudden they come at you fast and furious. Some people that are used to drinking from a fire hose, so to speak, this doesn't faze them. But for me, I was like, well, I gotta hear something, I gotta master it, and then I got it for life, that sort of thing. And when there were 7 things thrown at my face really quick, I didn't do too well with it. Did I get yours down? So that's why I've got scheduled and I'll just say we are not quite far ahead of schedule, but we're ahead of schedule. I mean, we can do as many review days if we feel. I mean, but you guys got to talk to me like, hey, we are completely, totally lost. It's too much stuff. We need to do a review day. I can certainly always do that until we get far behind. We're way ahead. There's only 13 chapters, and we're already on, chapter 5. I'm supposed to be at chapter 6 or 7 by December, and we're going to easily make that. All right, so it's called Ways to Prove Quadrilaterals or Parallelogram. It kind of tells you what we're going to do today. So last class we started with this shape. It is a quadrilateral, but it's a special quadrilateral called a parallelogram. And a parallelogram, by definition, says that opposite sides are parallel. So opposite side by definition. That's all the definition says. But we have a page in our book of truth now that we have at least 3 statements, yes? About the so what about parallelograms?
Yes.
All right, Madison, give me one of the so what's about parallelograms. So she's going to open her book because you're going to forget this stuff. And she knows where to look. And she's going to say, for instance, opposite sides are congruent. There's one so what. Wes, give me another so what.
Opposite angles.
Okay, opposite angle. This is the only one you got to be careful at. Remember, opposite doesn't mean adjacent. It means opposite. So these 2 angles are congruent. And these 2 angles. Now, visually look at it. I will just say, if you haven't already noticed this, all parallelograms have 2, talking about angles. What kind of angles? Could be if it's a rectangle. I have 2 obtuse and 2 acute. Have you noticed that? So this one and this one are acute. This one and that one are obtuse. We get to a rectangle, then we get 4 right angles. So if you haven't noticed that, now you have. There's a third so what. Chris, what do you got? What's the third so what? We got opposite sides are congruent, opposite angles are congruent, and what's the third one? You're right. We've been using this for vertical angles, but it's actually.
The diagonals of a parallelogram bisect each other.
So if you draw the diagonals and the diagonals bisect, now be careful. It doesn't say that the diagonals are equal, right? That's true if it's a rectangle or a rhombus, but it's not true if it's a standard parallelogram. But it says that they bisect each other, okay? Oh, and lastly, remember we have a symbol for parallelogram. All right, pretty good. You guys named them all. There's actually 4. We'll get the 4th one today. So we got opposite sides are congruent, we got opposite angles are congruent, and we have the diagonals. I can't, it would be too messy if I drew it right there, so I drew another one. So the diagonals bisect each other. Are we good with the basic idea? Or, I mean, maybe you can't remember all 3 of them, but they're on your paper, and you understand each one, yes?
Yes.
Okay, so we're gonna get a 4th one, here it comes. So here's the new one. We're going to add it to our list of 3. So I got to prove it to you. I'm not going to do a formal proof, but here's the idea. Okay, we know that if you have 2 parallel lines cut by a transversal, what? Say again? Okay, true, but I'm saying if I tell you that the black line is parallel to the black line and the red line cuts it, called transversal, what do we get from that construction? Alternate interiors are congruent. What else? Same side interior are
Alternate exterior.
or supplementary, and then we get one last one.
Alternate
Course,
exterior.
we do get that one, and I wish that our book went into more detail, but it doesn't. The alternate exterior angles are congruent, but we get the corresponding angles. I'm going to choose one of those. I'm going to choose say it. Same side interior are. That means that 1 + 2 = 180, right? And I'm being lazy or not saying measured angle 1 plus measured angle 2. Remember that? Well, what's a parallelogram? Is it not 2 parallel lines cut by a transversal? Can you see that this is actually the same shape? I just left off the other transversal. So what can you tell me about on a parallelogram about angles 1 and angles 2? They add up to 180. Well, what can you tell me about angles 3 and angles 4? They add up to 180. Now, tilt your head either to the right or to the left. What can you tell me about angle 1 and angle 3? They add up to 180, and I ran out of space. I couldn't write 2 + 4, but 2 + 4 also equals 180. So because of this, and it's a parallelogram, we get our 4th, put in your book of truth, we get our 4th one. We're not going to call it same side interior, right? We're going to call them consecutive angles. Consecutive just means which one is next to each other. Some books will call it adjacent angles, adjacent interior angles. So it's either consecutive or adjacent interior, either one. But you pick any 2 interior angles that are next to each other, they're going to be supplementary. So these are the 4 statements that you get. Danny, you writing this down? Nice. I could have given you this. This would have made homework slightly easier with this statement right here, but I chose not to give it to you and save it for another day. I didn't want to give you too much. Okay, that's all we're going to get for parallelograms, right? We're not going to get any more. Say it's just these 4 right here. Are you going to remember these? Well, few of them, sort of, but you're probably going to forget the diagonals bisect each other, and you might forget the consecutive angles or adjacent angles are supplementary. Everyone remembers the opposite sides are congruent and opposite angles, which is why I wanted you to have it all on a special page. Now, how much of your page you got filled up right now? Okay, good, because we're going to use up that other half. All right, so last class and up to right now, all we've done is saying these are the properties of, I give you a parallelogram, now you can say these 4 things. Now we're going to switch gears and do something else. Get it? Okay.
I don't do switch.
All right, so what we're going to do now is I'm going to give you a
Parallelogram.
how do you know it's parallelogram?
4 angles.
I'm going to give you a
Quadrilateral.
I'm going to give you a quadrilateral. You're going to prove that it's a
Parallelogram.
that's what we're doing. So that's the switch. Before I gave you the parallelogram, you told me something. Right now I'm going to give you a quadrilateral. You're going to prove it's a parallelogram. That's all today, right? Unfortunately, there's 5 of them, right? So this can get really not confusing. It won't get confusing, but there's 5 of them. No one is going to remember 5, which is why we made a special page for parallelograms. So when you're asked to prove that something's a parallelogram, you're just going to flip to that page, it's a parallelogram, and you're going to choose one of these 5 techniques. All right. So remember, quadrilateral has 4 sides. We're going to prove that it's a parallelogram. Turns out there's 5 ways, right? Yeah, I'd be doing that too. Right? No one's going to remember 5 ways, right? And they all come from the basic definition that it's a parallelogram. Okay. All right. So what are we doing? I'm going to give you a quadrilateral. You're going to choose one of 5 ways to show me that it's a parallelogram. It depends upon what I give you. There's 5 of them. So here we go. First way. And I got to do it as a proof, right? What's the definition of a parallelogram?
The opposite sides
Are
perpendicular.
what? No, that's not what the definition says. What's the definition of parallelogram? Opposite sides are parallel. So that's what we're about to prove. That if you have opposite sides that are parallel, it's a parallelogram. Okay? Notice what my start is. I'm giving you a quadrilateral where opposite sides are congruent. Okay? So if opposite sides are congruent, is it a parallelogram? Turns out yes. By the way, that's what we're about to prove. All right, who wants to be on the hot seat? Bailey? What's our tried and true technique? What do we do in geometry when we try to prove things in general? No matter what page you turn after chapter 2, if you open up the book to any page, guess what? I'm literally doing it right now. Guess what you see? Open up your book to any page and guess what you see. Oh, I just opened up one. There's not one there. Page 571 is the only one. But 572 and 573 have them. Triangles. Thank you. So guess what we're going to make?
Triangle.
How would you make a triangle? Which one do you want to make? You got to draw one. So what do you want me to draw? F to H. So she wants me to, oh, here's the given, right? She wants me to make a auxiliary line, diagonal in this case, and she wants me to connect F to H. Okay. Just so you know, the only way we show right now, because we have no tools, the only way to show something's a parallelogram is meet the definition of parallelogram. That means that opposite sides are parallel. So I already know how this proof is going to end. How do I know that? Because that's all we have. Remember, there's going to be 5 ways. This is the first way. Once we get this done, then we're going to have a few more tools in our, or a few more arrows in our quiver. But right now, we don't have anything. We got to meet the definition of parallelogram, which is opposite sides are parallel. Bailey said, well, I don't know what to do, but in geometry, it seems like we're always going to make triangles. Let's make a triangle. Now, I chose the other one, but Bailey's would work as well, too. I chose to make EG instead of FH. It will still work with FH. So I'm going to make EG, right? Notice we get how many angles with that construction?
2.
How many angles do we make with that construction? Good. 1, 2, 3, 4, right? I'm going to label them, right? You've seen me do that before, right? It just makes my life easier to have those labels. All right, so that's my basic construction. This proof is actually not too challenging. How do I show that FG is parallel to EH?
Transversal.
Say again?
Transversal.
Oh, we got transversal now. So I don't know if you remember this is a couple chapters ago. To show that two lines are parallel, either show that alternate interior angles are congruent, same side interior add up to 180, or corresponding angles are congruent. Which one do we have? Well, we don't have any of them, and I can't say that 3 is congruent to 2.
We gave them this.
Oh, so we go back to technique number 2 now, right? Is try to show that those two parts, angles 3 and angles 4, and then 1 and 4, I'm sorry, 3 and 2, and then 1 and 4, are part of two different triangles. Show me that the two triangles are congruent. So Wes has already seen how this proof ends. Can you show that this triangle is congruent to this triangle? Chris? Can you show that this triangle is congruent to this one?
Oh, yes. Wait, what are we doing? Yeah.
Wes already knows how this ends. Matt, do you know how you can show that this triangle is congruent to this triangle? Well, there is a reflexive property, so maybe we say that. So EG is congruent to EG. Back to Chris. Are the two triangles congruent now? Why? Where do you see any angles that are marked congruent? Okay. What do you see that's marked congruent, though? Congruent would be those little tick marks. We got 5 of these. Name them all. Name all 5. How do you show two side angle side? All that stuff. Yeah, give it to me. Side angle side. Come on, Chris, you can do this. Side angle side. You just took a test on it. I know you know this.
Yes, I do.
I know. So give them to me, please. What? Hypotenuse leg. That's the one everyone forgets. So we got side angle side, hypotenuse leg, give me the middle 3. Thank you. Okay. Side, side, side. Notice we got SSS. So we could say that those two triangles are congruent by SSS. Yes? Okay. So once that's the case, I can now claim that angle 3 is congruent to angle 2. Why can I claim that 3 is congruent to 2? Why can I claim that 1 is congruent to 4? And that's where it kind of falls into place right there. Therefore, if 3 is congruent to 2, that means that FG is parallel to EH. Why? Because alternate interior angles. Two parallel lines cut by that transversal. You just showed me that 3 is congruent to 2 right there. Therefore, FG is parallel to EH. Tilt your head right or left, and then we got another 2 parallel lines cut by a transversal. You just showed me that 1 is congruent to 4, therefore alternate interior. It's the converse to the alternate interior angle theorem. I forget what number it is. Okay. And we're done. Oh, by the way, what did we just prove?
And it's a parallelogram.
That it's a parallelogram. But how did we prove it? What were we given at the very start? What were we given at the very start? If you have a quadrilateral that has opposite sides that are congruent, therefore that quadrilateral is and that's our first method. Okay. So this is theorem 5.4. It's the converse to 5.1, and it says this: if you have a quadrilateral and opposite sides are congruent, then it is a parallelogram. So tonight for homework, they're going to give you a quadrilateral. You're going to see that, oh, by the way, opposite sides are congruent. You can conclude that it's a parallel. This is method 1 of 5. Well, it's technically method 2. Method number 1 is you show that opposite sides are parallel. So you meet the definition. This is number 2. You got it written down, Danny? 5-4 says that if opposite sides are congruent, it's a parallelogram. We got 2 down, we got 3 left. So now we're just going to do a bunch of writing. We're going to go over the 3 other methods. You're going to write them down, okay? And then you get to pick which one we want to prove. Whatever we don't prove, you got tonight for homework. So there's 5 of these. We just proved 1 of them. We'll prove 1 more, so you're going to have 3 proofs tonight for homework. They're all pretty simple. Who gets to pick? Who wants to pick? All right, we'll see. All right, so let's do some writing. This is Theorem 5-5, right? 5-5, you're gonna, if you don't choose this one to do in class, we'll prove it tonight for homework. And it says this. Look at the board, please. It says, if you have a quadrilateral and you have 1 set, not 2, previous one you had to have both sets, you have 1 set of sides, opposite sides, that are both parallel and congruent. If 1 pair of opposite sides are both parallel congruent, it's parallelogram. You got to have both conditions. That the set of sides that you choose are congruent and they're parallel, then boom, it's a parallelogram. This is an easy proof. Do not choose this one. They're all actually, all 3 of them are easy. Yes? There's going to be 5 of these. This is number 3. The first one is just the definition of parallelogram. It will be rare that you ever use that one as proof that it's a parallelogram. Good? And these are in the book too. All right. 5-6, converse to 5-2. It says this. If both sets of opposite angles are congruent, it's a parallelogram. Okay, this one you got to show, once again, just like the previous one, you got to show 4 things. I got to show that B is congruent to D and A is congruent to C. If you can show that, then it's parallelogram. This one looks like it's a hard one to prove. It's not too bad. You got 3 of them you got to prove for homework. We're going to pick 1 of them. So that really means you've got 2 to prove tonight for homework.
So it only gives us 3. So are we doing like?
Well, if you look at the number 10, is there?
I guess.
So it's these 3, there's 4. We're going to pick 1. Chandler's trying to figure out which one's the hardest one. So maybe he gets to pick.
No, I'm trying to figure out which one we're actually going to do so I can do the other one instead.
Well, then if you pick, then you'll know. All right. Last one. Here's it's the messiest one. It's actually not too hard to prove. You got to show me that the diagonals of a quadrilateral bisect each other. You can't just show that one bisects the other. You got to show that both bisect each other. So if you just show me that this piece is congruent to this piece, that's not enough. You also got to show me that that piece is congruent to that piece. Okay? So if you can show me that the diagonals bisect each other, then it's a parallelogram. So that's 4 theorems, and there's going to be 1 definition. Oh, by the way, we have proven 5-7. Or I'm sorry, 5-4. So where it says you got to prove 5-4, we already did it. Yeah. I got really lazy on my homework and didn't want to write it down. Plus, I want to give kids a chance to pick. All right, before we actually prove one of these, because I said we would prove one of these, we need to write this in our book of truth in a much more close format. So on your page that you have parallelograms, right, we're going to write that. All right, so somewhere in your book of truth, right, on your parallelogram page, you should have all 5 of these written. So I'm going to pause. Yes, I'm making you write it down for a second time, but I'm saying this is easier than to flip through a whole bunch of theorems. You just flip to the page, it says parallelograms. Oh, I got to prove that a quadrilateral is a parallelogram. I flip to that page, and you'll have these 5 listed. The first one is just the definition. Like I said, I can't think of a time that we actually do this, but we could. If you could show me that both pairs of opposite sides are parallel, by definition, it's a parallelogram. So this would be what you need to do in the proof. This would be your reason for it. Oh, by the definition, I showed that opposite sides are parallel. The second one, well, that's theorem 5.4. Show me that both pairs of opposite sides are congruent. You've done that. Nobody remembers it's theorem 5.4, which is another reason to have this in your book of truth to speed things up. Number 3 is just show me that one pair is both parallel and congruent. It's parallelogram. That's theorem 5.5. The fourth way, there's a lot of ways, right? Show me that opposite angles, both sets of opposite angles are congruent. That's 5.6. And then the last one is you got to show me that the diagonals bisect each other. You don't have to do all 5. You got to do one of them. I'll give you a quadrilateral. You get to prove that it's a parallelogram. It's going to be one of these 5. It probably won't be the first one, but it could be. Usually what happens, they give you a picture and they already show you that the opposite sides are parallel, and then you claim by definition. I think there's one practice one like that. Is there? Is there? No. Oh, I'm on the wrong page. Is there? Yes, there is. What do you know? Okay, that seems like a lot, and it is a lot. And like I said, this is where, when I was in high school, it's like, well, that's just too many. My head's kind of swimming. I need a day or two to digest all this so I'm not confused. We already proved 5.4. So what I'm saying is pick one. So you don't have to do that one tonight for homework. Chandler, that's number 11?
No, yeah.
So number 11, you don't need to do tonight for homework because we just did it. And now you get to pick one of these and we'll prove it. Connor, which one do you think is the hardest? Pick one and we'll prove it. Which theorem? 5.7. Let's prove 5.7. All right. That means tonight for homework, you're going to have 5.5 and 5.6. That's numbers 10 and 12. Okay. All right. So we're going to prove 5.7. The one that looks ugly. All right. Let's prove this sucker. This is just proof. All right. So you will be given that the diagonals bisect each other. You got to prove it's parallelogram. Okay. Any thoughts?
Where they bisect each other is the midpoint.
Okay. So this point right here is a midpoint. I agree. We'll call it O. Anybody else? What? Yeah, but that's literally the one that we're trying to prove, right? So great, they bisect each other. Why is it a parallelogram? Well, how do you show it's a parallelogram? Well, we can show that opposite sides are congruent, it's parallelogram. That's 5.4, right? If we could show that this is congruent to this, and this is congruent to that, well, we can claim 5.4 and we're done.
Oh, wait, the vertical angle would be congruent.
Ooh, vertical angle, I didn't even have to ask for that. So we got vertical angles congruent there and there. Okay, that looks weird, right? So what? So immediately we see side angle side, therefore that is congruent to this because of, oh, side angle side, therefore that's congruent to that because of, and you're done. We can claim 5, 4, and we're done. We just show that opposite sides. So that was a very easy proof. You chose an easy one. Sorry. Hint, hint, hint. The hard one is tonight for homework. This one.
Oh, yeah.
Here's the hint. If you add up all 4 angles of a quadrilateral, it must get you to 360. These are the same, and these are the same. Use that to do some algebra, simple algebra, to get to your answer. Okay, there's your only hint. Okay, not bad. So we have that. Now, literally, that's the whole class. What's left is, well, what good is it? What do I do with this? Well, they're going to give you a picture. And the picture is going to be of a quadrilateral. They're going to ask you to prove that it's a parallelogram. This is your ammo to do that. One of these statements. Okay? So, get your books open. Let's turn to page. I need you to look because my diagrams are usually kind of messy. Get to page 173 and I'll show you what homework looks like. Other than the proofs, of course. So here's all the pictures, and like I said, mine's curved a little bit here. So, and we'll just do these 9 and call it a day. All right, remember, these are the reasons right here. I can't shrink it down. There's too many of them. Right? Those are the reasons. So this is a yes or a no. But if you say yes, you got to say one of these. Okay? So, Karis, you're my guinea pig. First one. Is that a parallelogram? Why? So she's claiming because of which one? 1, 2, 3, 4, 5. You see a bisect?
No, I said 5, 6.
5, 6 says that both pairs of opposite angles are congruent. 5, 5 says that one pair of angles. You said it right the first time, but
5, 4.
it's 5, 4. She literally took her hand. She said, because that is the same and that's the same. So she's, well, I guess she could be showing me angles, but I know there's no angles. She was showing me that both sets of opposite sides are congruent, right? That's 5, 4. Okay? Pretty easy, right? All right, and the rest become increasingly more challenged. Caleb, number 2, yes or no? Why? Let's see what 5, 7 says. 5, 7 says that diagonals bisect each other. And I don't see any, well, I see diagonals, but no marks on them. Tell me what marks you see on number 2. Marks would be in red. And what does it say? They're parallel, and it also shows in red. How big is DC? How big is AB? If they're both 9, that means they're congruent. So you just said that these one pair of sides, opposite sides, are parallel and congruent. Which one? 5, 5 says show that one pair is both congruent and parallel. Good job. Yeah? We're going to do more of these on practice day as well, too. All right. Guinea pig? Maddie? Number 3? Yes or no? Yeah. Well, I can see one set of opposite sides is congruent. So if we could get that they're parallel, the only way we're going to get that they're parallel is if we show that alternate interior angles are congruent. So you got to be able to tell me something about this angle and this angle. If you could tell me if those are congruent, you know, because the two triangles are congruent. I see a triangle, I see a triangle. You see any angles there that are congruent? I see one. I see vertical angles right here. Does that help us? Does that get us an SAS? That actually gets us an ASS, right? So it turns out that were we able to show that that angle is congruent to this angle? Yes or no? We weren't. So therefore, I can't claim that that side is parallel to this side. Is there anything else we got there that might get us to anything? No. We only have one side of this triangle. We only have one side of this triangle, so I can't say anything. You can look at the bigger triangle. Well, that side and that, well, that's only one. You got something, Wes? You don't, well, it's certainly the midpoint of this one of DB, but I don't know if it's the midpoint of AC. So I guess what we're trying to say here is what? Well, it may be just not with the given information. So this one is a no. 3, a lot of stuff there. It just doesn't get us to one of our 5 things. So 3 is a no. Am I right? Yes, no. All right. Guinea pig are getting progressively more challenging. More challenging. Micah, number 4. Kind of looks like this one, sort of. He says immediately it's 5-7. Well, let's see. What was 5-7? The diagonals bisect each other. Is that what it shows? That they're bisecting each other? Yes, class?
Yeah.
Heck yeah, that's a 5-7 right there. Seth, number 5. Oh, by the way, so yes, 5-7. Seth, number 5. Number 5.
Okay. So we got 2 congruent angles.
We got 2 congruent angles. And they're opposite.
So if we're looking for both pairs.
So we need to say something about this pair if we want to use whatever that theorem is.
Yes.
Right?
And if we know all the sides add up 60.
We do.
So can we add up 70 and 70 and then subtract each side from them?
So if they were congruent, then we certainly could come up with that. But the case is, do we know that they're congruent?
Yeah.
Well, if it was a parallelogram, yes. I mean, 70 and 70 is what, 140? 160 minus 140 is what? 220, right?
Yeah.
And 220 divided by 2 is 110. So if this is 110 and that's 110, they're congruent. But the question is, can you show me that they're 110? And the answer is, you can't. Right? So this one also 5 is a no. And we're almost there. We would like to be able to say, show that number 2, 5, 4, that both, I'm sorry.
Did you say 5, 6?
5, 6. Well, we can't because all we have is one pair. Now, if it's a parallelogram, we would have both pairs, but that's the thing we're trying to prove. Okay? And I guess what I'm saying is, this is not 70, this is more like 90. If you take 2 fixed angles, well, certainly we can make a parallelogram out of them, but we can also make something that's not a parallelogram just by moving this. I'm changing 2 of the angles so they're not equal to each other. Okay? Even though these remain fixed at 70. Although my hands were showing nice.
6 is the T's.
All right, I think what Seth was trying to do is number 6 logic, though. So make sure you look closely at 6.
Yeah.
So go ahead, Seth, do 6 now.
So if all the sides add up to 360,
Angles
add up to 360, then you just had to add 70, 10.
When I'm only missing one angle, we can certainly do some math and figure out what angle C is, and angle C ends up being 110. So therefore, yes or no. By 5, 6, we just showed that both pairs of opposite angles are congruent. We're good. Okay, we got 3 left. 3 left. I'm going to claim, Matt, that 7 is easy. Why is 7 easy? So is it a parallelogram?
It's a quadrilateral.
Certainly quadrilateral. He said it looks like a rectangle. Is it a rectangle? Why is it a rectangle? A rectangle has 4 right angles. Why? You're right, by the way. But why?
We haven't gotten this far.
Hey, somebody tell me why angle D and angle C are 90. Yeah, no. I mean, that's true what you said, but not because of this.
Because everything has to add up to 60.
Yeah, but why is D and C the same thing?
Because both of them.
Well, that's true if it's a parallelogram.
Oh, yeah, no.
We don't know it's a parallelogram yet.
But we know that it has that we can cut a make a transversal line.
Okay, so we got two parallel lines cut by transversal. If A is 80, then what can you say about D? I said 80, I meant 90.
Well, ulterior.
It's not alternate interior, it's same side interior are supplementary. So if A is 90, then D's got to be 90. Same logic for B and C.
Wait.
So therefore, you showed all the angles are 90, Matt. Why is that a parallelogram? One of the 5 things. You just basically showed me that all the angles are 90. Well, actually not you, but Seth and Katie showed us that. But great. Now that we know that all the interior angles are 90, why is it a parallelogram? Say again? 5-4 says that opposite sides. We didn't show anything about sides. You showed me that all the interior angles are 90. Which one would that be? What's 5-6 say? Show that both pairs of opposite angles are congruent. Are both pairs of opposite angles congruent? Because they're all 90, that's what we'll use. Right?
But you also say 5-4.
5-4 says that both pairs of opposite sides are congruent. You got to tell me where we showed that the sides were congruent. Now, we said they're parallel. Could you do this another way? Sure. If you wanted to draw a diagonal, right? Then you could prove if this one is 90, then this one is 90. So I got an angle, and now I got to prove sides. So we got 2 parallel lines cut by transversal. Therefore, that angle is equal to that angle. I got an angle. Can I get to a side that way? That's the issue. You got a reflexive. So now I have a side, the hypotenuse of the triangle, but I don't get to any one of the legs. I mean, that one's hard to do. Okay, but we can get to it through using that opposite angles are congruent. Okay, and that's what we're gonna do.
Good question.
Yeah.
So when you have a transversal with 90 degree, we just get a perpendicular line. We just skip the step of trying to prove if we need to.
Depends what we're proving. If we're proving that it's a parallelogram, then we gotta use one of those 5 things. If you're trying to prove something else, then we have other options as well. All right, we're getting progressively harder. Progressively harder. Cadence number 8. Yes or no? Why? Mike is already saying side angle side.
That was me.
Oh.
That was me.
Yeah, it's angle side side, right? It'd be a reflexive angle side side. So yeah, that one's a no. Well, that was easily done. Number 9 is the hardest one. Micah.
Because you're smart and have glasses.
The hardest one. Chandler, help him out. Yes or no?
Yeah, help me. I don't know. Look at me. I'm not even thinking about this right now.
Yes or no? This one's hard. This would be, I'd put this on an honors test right here, number 9.
What is your number 9 first?
It must be. It's also odd, so it's back the book.
So wait.
I'm going to use my standard technique of pull the triangles apart. So I get this triangle, and then I'm going to pull apart the one next to it, this one. You would get reflexive, and then you would get this angle, and you would get this angle. What else would you get? You get that angle, you get this angle, and I got an ASA right there. This one I don't have an ASA. We'll pick this one up tomorrow. All right. Good luck on your homework. Make sure you actually look at it during student advisement so that I can give you assistance.
Still trying to figure it out.
It's ASA. I just pulled the wrong two triangles. It's top and bottom. So if I pull this one and this one, you already have the two angles right here. You already have the two angles right here. That would be reflexive, so it would be ASA. Therefore, that's congruent to this, right? Therefore, this angle is congruent to this angle. Therefore, alternate interior, so therefore that side's going to that side. That one's hard.
Yeah. No, but I was pulling the triangle apart like incorrectly. I pulled BCB and BAD apart, right? Then I realized, wait.
Well, yeah. Well, you only get one angle, therefore it would be congruent.
Yeah. And then
And then reflexive.
Then you were like, oh. Then you did the other
Yeah.
set of triangles. I'm like, why didn't I just? Okay. Well, have a great day.
You as well.
Yes.
I'm pain right now. Like airsoft this Saturday. Long journey Western and all that.
Do you have marks on your body?
Oh yeah, 15 of them.
Where? Show me one.
3 very easily visible. Actually 4. One on my neck. One was there yesterday. There's one there.
Who got you?
Name a person that was there.
Oh, were you playing on the same teams or opposite teams with Danny?
I was on the same team with Danny.
And he shot you.
No, Weston shot me.
Weston had an accidental discharge and shot you. That's horrible. Let's see.